Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be talking about today is notes 14.2, which is over pH, pOH, OH- and H+ concentrations. So go ahead and answer those bellwork questions, then we'll start talking about our objectives. So our objectives for today is this. Sub-objective 1 says you need to be able to estimate the H+ concentration of a solution. Sub-objective 2 says you need to be able to estimate the OH- concentration of a solution. And then our goal for today is be able to calculate the pH, pOH, H+, and OH- concentration of a solution. Now, I want to talk to you a little bit about some notation stuff today about how you might see stuff. Whenever you see something in brackets like this, especially in chemistry, like in this lesson and in this unit, that means the concentration of that thing. So that means typically that's going to mean the molarity. What's the molarity of H+? What's the molarity of OH-, okay? Or what's the concentration of that thing? So let's go ahead and let's get started. So you guys have heard of probably pH before. You've probably looked at it in some other classes maybe before, maybe in junior high or other areas. Here's some pHs of some common substances. So like something like vinegar has a pH of 2.8. Okay? What we learned about in our first lesson is anything below a pH of 7 is acidic. So all of these things are acidic. So vinegar contains acetic acid, it's acidic. Soda contains carbonic acid, contains phosphoric acid. So that's going to be acidic. Then you've got oranges. Oranges contain citric acid, they're acidic. Okay, then you've got kind of a crossover here, like the pH of our blood is around 7.4, so now we're crossing over into like the basic area. Then ammonia has a pH of 11. Oven cleaner has a pH of 11.7. So these are just some common substances that you might measure a pH of at some point. I mean, I guess not really your blood, but it is important that we maintain a pH of 7.4. So what we're going to be talking about is the pH scale. Now, the pH scale works on factors of 10. So here's what that means, okay? So on this scale, you've also got one on your notes page. On this scale, something that is a strong acid and is 1 molar actually has a pH of 0. So if I had 1 molar HCl, it would have a pH of 0. Then something that has a pH of 1, okay, is actually getting less acidic. Okay, things that are lower on this pH scale are more acidic. The lower your pH, the more acidic a substance is. So instead of something, so like let's say we were looking at the transition from 1 to 2. You might say, well, if something had a pH of 1 and then it went to a pH of 2, you might say, well, its acidity got like halved, like it went down by a half. Because remember, pH, the lower the number is, the more acidic. So that's actually not the case. These actually work by factors of 10. Meaning that something that has a pH of 1, if all of a sudden it goes to a pH of 2, that means it's 10 times less acidic. If you go from a pH of 2 to a pH of 3, that means it's 10 more times less acidic. Okay, so it works on factors of 10. So that's because it uses something that's called a log scale. We'll be using logarithms today. You guys have probably used those in math before. If you haven't, they're really not that hard. You don't have to really know a lot about how they work mathematically. You're just going to have to know how to put them into your calculator. So we'll be using pH, the pH scale a lot in this unit. So acids and bases we talked about last lesson, and we looked at 2 types of acids. So binary acids are acids that contain hydrogen and another element. So that'd be something like HCl. Then you've got stuff that's called polyprotic acids. Polyprotic acids are acids that have more than one hydrogen attached. So a polyprotic acid would be something like H2SO4. So notice how HCl only has 1 hydrogen, but H2SO4 has 2 hydrogens that could pop off. So that way, that means that H2SO4 has twice as many hydrogens that it can give away and put in solution. So our first objective for today was you're going to have to be able to estimate the H+ concentration of a solution. So Many times problems don't directly tell you the H plus concentration. Like they don't come out and say, hey, the H plus concentration is this. Sometimes they'll say something like this. You have 1 molar HCl. What's the pH? Well, here's something that you guys need to learn how to do is, you need to go, okay, if I have 1 molar HCl, how many moles of hydrogen are in that compound? Well, if I have 1 molar HCl, hydrochloric acid, or HCl, has 1 mole of hydrogen for every 1 mole of HCl. So that means if I have 1 molar HCl, that means I also have 1 molar H+. Now let's look at something else. So in the previous slide, we talked about H2SO4. Okay, H2SO4, sulfuric acid, has 2 hydrogens that can pop off, which means if I had 0.2 molar H2SO4, I don't have 0.2 molar H+. I actually have 0.4 molar H+. That's because, basically, to put this as simply as possible, I'm going to take the molarity of my compound and multiply it by the subscript of my hydrogen to get my H+ concentration. Okay? Now, the same thing works for hydroxide or hydroxides. Okay? Aluminum hydroxide has 3 moles of hydroxide, or OH, for every 1 aluminum hydroxide. So if I had a 0.3 molar aluminum hydroxide solution, that actually means my OH minus concentration is 0.9 molar. And that's because every mole of this contains 3 moles of hydroxide, so I take 0.3 times 3, that's what got me my 0.9. So you're going to have to be able to do that for some of your problems to change in order to answer the questions that you're asked to answer. So let's actually get to our calculations. All right, so in this unit or in this lesson, what you're going to have to be able to do is you're going to have to be able to convert from H+, pH, pOH, and OH minus. So what I have for you guys is I have something, I just call this the pH square, okay? Here's how it works. Whatever you are given, you start in that corner, okay? So if I go back to a problem and I say, let's say I'm right here on this second or third bullet point, and I had 0.2 molar H2SO4. Well, I'd have to find the H+ concentration of that. And from the skills we just used, we found that, okay, if it's 0.2 molar H2SO4, that means it's 0.4 molar H+. So that means I'd be starting here, and I'd have 0.4 molar H+. Then I can convert around this square using the conversions that are on this line. Okay, so if I had my H+ and it said find the pH, well, I would look at my H+, and I would follow the arrow, which is right here, that goes from H+ to pH. And it says, to find the pH, it is equal to the negative log of my H+. So what I would do is I would take the negative log of my H+ concentration, and that would give me my pH. Then, if I wanted to go to pOH, well, to do that, I would follow this arrow. Well, this equation can be used for either direction. So I would take my pH, plug it in right here, so I'd have my pH plus my pOH is 14. So I would solve for that by taking 14 minus my pH, and then I would get my pOH. Then you can continue doing that. We're going to walk through some problems right now to show you how to use this. So here are the problems we're going to work through. It says, if the HCl concentration is 3.9 times 10 to the minus third, what is the OH minus concentration? Okay, so the first thing I would need to do is I would need to estimate my H+ concentration. Well, it says the concentration of HCl is 3.9 times 10 to the minus 3. Okay, and that would be like molar. What is the OH minus concentration? Well, I'm going to go back to my pH square. It gave me my HCl concentration, right here, 3.9 times 10 to the minus 3. And I'm going to estimate that to be my H+. Remember, since I have 1 mole of hydrogen for every 1 mole of HCl, that means this concentration is my H+ concentration. So what that means is I have my H+ concentration right here. This is 3.9 times 10 to the minus 3. Then what I'm going to do is I'm going to convert from my H+ to what the problem asked me to find. And it said to find my OH minus. So that's right here. Now, we could go this way and use this conversion. What I'm going to do, just to show you how to use multiple, like all of these conversions, I'm going to go around the square this way. So here's what I'm going to do. I'm going to take my H plus concentration, and I'm going to follow the arrow, and it says to find my pH, I'm going to take the negative log of my H plus. Then that'll give me my pH. Then once I know my pH, I'm going to plug it into this equation and solve for my pOH. Then I'll know my pOH, then I can convert to OH minus. Okay? So, I'm going to show you how to do this on my calculator right now. So, I'm starting here at H plus. What I'm going to do first is I'm going to take the negative log of the H plus concentration. So my H plus concentration was 3.9 times 10 to the negative 3. So I'm going to take the negative log, so again hit negative, and then here's my log button, of 3.9 times 10. Then I'm going to hit this x to the y button, and then negative 3. So this is my first conversion. Right now, this would be my pH. So the pH of my solution would be 2.41, basically. Now the next thing I need to do is convert from pH to pOH. In order to do that, I would plug in my 2.41 right here. Then to solve for my pOH, I would have to move that 2.41 and subtract it from the other side. So basically, I'm going to do 14 minus 2.41. Now, just to keep my number as accurate as possible, I'm going to show you a feature on here. If I take 14 minus, and instead of entering in 2.41, I'm going to hit answer. Now, if you can see on my screen, the answer right here is the answer to my previous question, which is 2.4089. So it kept my whole number. So this is why I like Google Calculators, because it can hang on to your numbers for you. So I'm going to do 14 minus that, which gives me 11.59. This would be my pOH. Now, in order to convert to my OH minus, I would now do 10, so I'm going to follow this arrow here, and I'm going to do 10 to the negative pOH. So I'm going to do 10, and then I'm going to hit x to the y, negative, and I'm going to enter in answer again, because instead of typing in 11.59, if you just typed in 11.59, it would work out. I'm sure it would be fine. I'm going to hit that answer button again, and I get my answer as 2.56, and then times 10 to the negative 12. So that would be my answer for my OH minus concentration. All right, let's try our next problem. So it says if the pOH is 8.7, what is the H plus? Well, let's go back. Let's look at our pH square. I have my pOH, it's 8.7. Okay, so I have that in, it's 8.7. I need to convert to my pH, then to my H plus. I could go this way. Okay, it doesn't matter which way you go. I'm going to go ahead and go this way though. So I would plug in 8.7 for my pOH. So I'd have my pH plus 8.7 equals 14. I would subtract 8.7 from both sides, which would be 14 minus 8.7. And 14 minus 8.7 is 5.3. That would be my pH. Then I'm going to convert from my pH to my H plus. In order to do that, it says to find my H plus, I need to take 10 to the negative pH. Okay, so I'm going to show you how to do that on your calculator. So in this problem, I have my pOH, it's 8.7, and I need to convert to my H plus, which is over here. So the first thing I'm going to do is convert from pOH to pH. So to do that, I'm going to do 14 minus my pOH. So my pOH again was 8.7, so I'm going to do 14 minus 8.7. And that gives me my pH as being 5.3. So now I would be right here on my pH square. Now to convert up to H plus, it says H plus along this arrow right here. It says to do 10 to the negative pH. So I'm going to do 10 to the negative 5.3. And that gives me 0.0000501 blah blah blah. So this number is again really tiny. If I was going to write it in scientific notation, I would write it as 5.01, and then I'd count how many decimal points I would need to move over. It'd be 1, 2, 3, 4, 5, 6. So this would be 5.01.
times 10 to the minus 6.
So, now that you've done that, we got that it was 5.01 times 10 to the minus 6. So, that would be my H plus concentration. Alright? Here's what I want you guys to try. I want you guys to try number 3 on your own. I will show you how to work through it on the calculator and up here on the board. Alright, so let's try number 3. So number 3 says the NaOH concentration is 1.4 times 10 to the minus 4. What's the H plus concentration? Well, because it said the NaOH concentration is 1.4 times 10 to the minus 4, we technically have our OH minus concentration that's been given to us. Since I have one hydroxide for every one sodium hydroxide, that means the concentration of my sodium hydroxide is my OH minus, which means it's given me this corner. Then it asked me to find what's the H plus concentration. Well, I'm going to show you how to do it going this way. This way is shorter, a little more complicated. If you chose to go around the square this way, we should get the same number. Let's check our answer. So what we should do is we should plug in our OH minus concentration, which our OH minus concentration was 1.4 times 10 to the minus 4. So that means this OH minus is 1.4 times 10 to the minus 4. So what I'm going to do is, in order to solve for my OH minus, I can rearrange this equation by doing this. If I divide my OH minus concentration onto this side, I will have 1.1 times 10 to the minus 14 divided by 1.4 times 10 to the minus 4, and that should get me my H plus concentration. So let's do that on our calculator.
Problem. Again, I am going from OH minus to H plus. So I need to do 1 times 10 to the minus 14 divided by my OH minus concentration. And my OH minus concentration was 1.4 times 10 to the minus 4. So don't forget, whenever you're operating or working with things in scientific notation, you need to make sure you use parentheses. So I'm going to type in my 1 times 10 to the negative 14. Then I'm going to divide by the OH minus concentration, which was 1.4. And again, make sure you use parentheses. Times 10 to the negative 4. And doing that conversion gives me 7.14 times 10 to the negative 11. That would be my H plus concentration.
So what I want you guys to do now is go ahead and try some of those practice problems that are on the back of your notes page. Let me know if you have any questions. Again, the reason why this unit can be really difficult is because of the weird numbers. You're not used to working with numbers in scientific notation very much. We haven't worked with those since we worked with particles extensively when we were using Avogadro's number. So give those a shot. If you have any questions, make sure you let me know. Thanks for watching.